good? All right, good morning. So, welcome to my talk. This is the PowerShell extension for VS Code deep dive. Can I get a show of hands how many people use the PowerShell extension in VS Code? Heck yeah, glad you're here. So this might be a bit of an interesting talk. I decided, like, when they said deep dive, to really go deep. A lot of this is going to be code. I'm going to treat this, I have a few slides, I promise, but I'm going to treat this as if you sat down next to me and you're the new engineer on the team, and I need to show you, like, start to finish, like, how the heck does this thing work? So obviously there's a lot we'll skip, but there's a lot that we're just going to dive through in VS Code itself, because that's actually where I do most of my development nowadays. And I guess I should introduce myself. My name's Andy Jordan. My pronouns are they, them, and I work at Microsoft. And we've got more intro on the next page. Oh, let's give a shout out to our sponsors. Thank you, Chocolatey, Centino Systems, Patch My PC, and Script Runner. This has been a great conference. We've all made it to the last day. So great. I'm here and awake, so love that for me. Click, click, click. Uh-oh. Click. Nope. Backwards. All right, yeah, so I'm a senior software engineer on the PowerShell team. I've actually been at Microsoft since an internship in 2014. I started full-time in 2015. My claim to fame was actually that I ported PowerShell to Linux and Mac OS way back in the day. And funny story about that, it's actually only on Mac OS. That wasn't originally an ask of us because my college laptop was a MacBook, and I had it working on Linux, and I'm like, well, this is so close to Mac, like that's where I do most of my development. So I just kind of decided to spend a night, and I was like, hey, look, it works on Mac now, can we like ship this? And you know, a year later, we did actually ship it. We took it, we pulled it out of Windows, we put it on GitHub, and I taught the PowerShell team how to use Git, because back in 2015, that wasn't a thing at Microsoft. But hey, here we are, it's 2023, I'm now on that team. Everyone at Microsoft uses and loves Git. We're full steam, open source. Most of Microsoft loves Linux. It's a great day. And lastly, just fun fact about me, and you can see my jersey in the picture there. I am an amateur bike racer on Breakfast Racing Team. You can catch me doing mountain bike, gravel, road, cyclocross, even on the track sometimes. Not sure how much I'll do that this year, the track. I love all the others. But yeah, so that's what I do. I bike, I code. That's my life. Let's take a look at what I've got. Click, come on. Oh no. You're probably right. Okay, sweet. Did we skip anything? Cool. The history. So, interestingly enough, this is, I think, one of the oldest extensions for VS Code. Like I said, we ported PowerShell over to Linux, Mac OS, and made it open source in about 2015. Right at the same time, an old colleague of mine, David Wilson, started writing this extension for PowerShell in VS Code. And turns out that first extension release, I just double-checked this, was November. And VS Code itself from Microsoft launched in April. So honestly, we were right on top of that. But the age of that means there's a lot of history, a lot of legacy, a lot of old design decisions that may or may not have been great ones, but they're what we have today. And I'm just honestly proud that we have this extension still, and that it's getting massively improved in the last couple of years, I think. Yeah, also shout out to some previous maintainers, Rob, Holt, and Tyler. I kind of took over Tyler's job on Steve's team when he went over to the VS Code team. He's still around, still helps us out a lot, is just kind of focusing on big picture code stuff, and I'm extension maintainer. Rob was also super great. He was my co-maintainer when I started on the team in 2021. He was in the middle of probably the 5th rewrite of this extension, and we kind of worked together to get it through that final rewrite, or I shouldn't say final, but most recent rewrite, where we have one pipeline that runs everything sequentially so things don't crap out on each other. It's great. Yeah, that we got that out in 2021, and then the last couple years has just been stabilizing stuff, which I know years, it sounds like a lot, but there's been a lot of work to do. I also just want to talk about kind of a little bit of major design motivation. Now, I haven't gotten to go back and interview David Wilson, and I would honestly love to. I need to catch lunch with him. But frankly, what we had at the time in Windows was the ISE. How many of you have used the ISE? Right? How many of you wanted the experience to at least be similar to the ISE? Yeah, so it was decided, well, we should like make it like the ISE. The big thing about that was having an integrated terminal. So you don't see this in any other extension on the marketplace. Like you install the Python extension, you don't get, am I about to lie? I'm not sure. Let's not use the Python extension. You install the C# extension, right? And it powers all of the stuff for C# in VS Code. But you don't get like some C# terminal popping up that shares the same state as the engine running the analyzers for C#. No, it's just all in the background. But we're not all in the background. We have a background process that's also a foreground process that is what you all know is now the extension terminal, previously known as PowerShell Integrated Console. We went through a bit of a rename. I can get into that. Yeah, so we have this foreground extension terminal. It's much like it was intended to be, much like the terminal that you found in ISE, where, yeah, your code that you're analyzing and the thing that you can type in share state. That's both good and bad. Clearly, there's a lot of like reasons to have it. People really wanted it, but because there's still like one PowerShell process, that sort of means that if you're running a script in the extension terminal, it can't service requests over LSP anymore. So the background event processing can't really happen. So like there was a cost to it, and we live with that cost today. We have ideas on how to maybe improve it, but that's where it is right now. And like I mentioned, it's gone through a lot of rewrites. Point it toward the computer. Cool, that's totally it. Just got to point that way. So let's talk about the team now, because that was the history. We've got myself. I'm actually an Emacs aficionado. So this was a weird but good fit. I was never paid to work on Emacs. I was never paid to play with my editor and my settings all the time. But that was probably what I did half the time. Like, in my opinion, if you have really good tools and know how to use them, you are like 10 times more efficient at your job. When I had a piece of code that I needed to like apply a macro to, instead of spending 3 hours painstakingly editing every function in a similar way through my code, I would spend 30 minutes making a proper Emacs macro and then do it all in less than an hour. So I've always been a fan of good developer tools. I've always been a fan of customizing and knowing your tools inside and out. Joining the PowerShell team was a bit of a natural fit. We are a developer and like administrative tool, and especially working on the editor, it's been one of my favorite things I've ever done actually as a software engineer. I get to make this tool that everybody wants to use, all the people in this room at least, and get to make it better. I love it. Also, huge shout out to Patrick Meineke, who's also an amazing community member, but is now on our team. He's a brilliant software engineer, kind of my partner in crime in the stabilization efforts of all of this. And somebody who's here, Sydney Smith in the front row, she's an incredible project manager. And honestly, I would probably get lost in the nitty gritty of everything if I didn't have her keeping me on track. So that's the team now, but it is an open source project. And I think we have several of these people in the room. This isn't all of them, but big shout out to Justin Grode, Keith Hill, Christoph Bergmeister, and Frode Flatten, and like everyone else who opens issues, opens pull requests, is even just hanging out on like the Discord and says, hey, this thing is broken, or I'm looking to do this thing. It's just really, really helpful for me, Patrick, and Sydney to like know how people are using the extension and what's broken. So if you have a bug, please don't shy away from opening an issue. Like, yes, it's more work for us, but that's what we're paid to do. Like, that's the work I want to do. I want to know what's broken. If I'm just guessing, it's not very fun. Yeah, so thanks to the community for working with us. We really, really love our contributions. Okay, let's get into some of the actual bits. I promise I only have like 2 more slides, and then we look at code, which should be most of this talk. So I have to define what the language server protocol is. It's honestly brilliant. I love LSP. Before I joined this team, like I mentioned, big Emacs aficionado, also Vim. Back in the day, it was kind of hell to set up your editor for a new programming language. They all had a different package. They all had to like reintegrate everything between the editor that you're using and the code that they're doing and the tools that use that code. Like, it was just this minefield of different pieces out there. And I should have copied like their documentation. They've got a great little matrix, but it was previously kind of an n-squared problem. Every single editor and every single language, and frankly, every single tool for that language, just big old crosses all the way through. You had to have somebody maintaining an Emacs extension for C#, PowerShell, Python, TypeScript, everything. Then you had to have somebody else maintaining a Vim extension for all of those languages again. And this is like an open source community. So actually, when we're talking about an extension in Emacs, there's like 5 of them for every language because there's all the tools on top of that. Microsoft came along and decided, let's make a protocol. It's called the Language Server Protocol. It turned this n-squared problem into a linear problem. It was, you write your server for your language. So now there is one team, or there's still usually a couple of pieces to it, but like there's one server for PowerShell, an LSP server. There's one server for C#. I think there might be 3, but you only have to have one for each programming language. And on the other side of things, instead of like for every language, it's just for LSP. You go to your editor, you make an LSP client. Because it speaks the same protocol, it can hook up to all of those servers. It doesn't have to speak the PowerShell language server. It just has to speak language server protocol. This simplified everything. Like it went like wildfire through the entire community of programmers using all of these different editors and programmers using all these different languages. We really quickly switched. Like I saw it happen in real time, and it was amazing. And I think it was one of the things that really got Microsoft into the good graces of the open source community, because they had a problem to solve for themselves. They came out with VS Code and they're like, we need people to write extensions for this. How do we do that? Oh, let's solve this problem for everyone. And now people wrote all the extensions for Language Server Protocol, and that means that they have extensions in VS Code and they have servers for all of these other languages, and everybody else gets to benefit for that. It's fantastic. I love it. I truly love LSP. It's not a perfect protocol. We definitely struggle with bugs sometimes and idiosyncrasies as every protocol, but yeah, I don't know where we would be today without it. So that is Language Server Protocol. Maybe I should just like high level what it does is you're in a client and you are like highlighting a piece of code and you have to do something for it. You need like a hover request, or you need IntelliSense, or you need to analyze it. All of those things are just a request sent from the client to the server, and it processes it and sends the result back over the protocol to the client. Just like that's the protocol, right? So in our case with the extension, we have VS Code. It's an LSP client, kind of. Really, specifically, we have extensions in VS Code. They're written in TypeScript. And most of them, at least our extension and every other extension that I've seen, uses an LSP client library that the code team has developed for us. So we don't have to like re-implement the client, like, you know, communication bits of it, but we do just have to say, here's how you do this for PowerShell for LSP in TypeScript. And then the other side of it is PowerShell editor services. It's the server, kind of. It's a PowerShell process, which hosts a module, which, yeah, is an LSP server eventually. And that's kind of the fun bit. I'm going to walk us through how we get from one side of that to the other in code. Point it at the thing. OK, yeah. So just to go over that again, Electron app at the top, written in Node.js, which means that we get to write JavaScript or really TypeScript, which is great. That's VS Code. It's hosting a TypeScript extension, or an extension written in TypeScript. That's the VS Code -PowerShell repository and all of the other extensions that you can find for VS Code. And then that connects to, in our case, over a socket if you're on Linux or Mac OS, and over a named pipe if you're on Windows. It connects to a server. In our case, that's a PowerShell process hosting a module called PowerShell Editor Services, and that is the name of the GitHub repository that you'll find. And again, you still need to like implement stuff on top of a protocol. We used to do that by hand, and there was a rewrite slightly before my time. It was mostly Tyler's effort to build us on top of a library called C# Language Server Protocol. That comes from the OmniSharp folks. It's sort of a black box for us. It means that we just implement handlers, and it implements like handle notification, handle request, get parameters, send it back. So it does like the actual communication bits, and we just do the PowerShell part of it. Now I say just, we still have to do most of the work. But it's been really helpful. It's also bitten us a lot. I've had to patch it a couple times. We're also not sure of its future. Its last release was November 2022, and it is community maintained. I like it. I want to continue to use it, especially since we're already invested on top of it. But yeah, that's just, a large piece underneath it. Oh, and to point out, it's a binary module, so we're talking C#. Okay, I think it's demo time. Yeah. Mirror. Don't need the remote. Is that a reasonable size for people in the back? Awesome. No? One more? Reasonable? Good theme color, solarized light? Cool. There was one file I actually didn't have pulled up that I wanted to pull up first. So my plan here is kind of we're in a 30 minutes Q&A. That Q is from you. The A is the code. I want to go through this at a really deep, high level, kind of a mid-level. Before I get into it, do people have specific areas of focus or questions that they want addressed? Because otherwise my plan is how it starts, how literally the extension host starts, and then move into like how a session within our extension starts, how that starts the PowerShell process, how that starts up a module, which starts a hosting assembly. I see you got a hand raised. And then we're going to move all the way into the host where the nitty-gritty bits are. But yes. How the IntelliSense works? Cool. Then we'll pull that up. When we get to that last file, which is in third to last file, you'll see all the handlers. We'll move into the completions handler, which powers IntelliSense. Others? Well, that's great, because I wasn't sure which handler to open when we got there. Okay, so, right, we're talking TypeScript here. We kind of have a document selector. And I'm just going to look at my computer screen and not that, because it's the same thing. We're talking about a document selector. Obviously, this extension runs for PowerShell files. Not too bad. Kind of the entry point, you can see I'm at the end of the file with it folded, is activate and then a deactivate. Pretty simple for a TypeScript extension. We just have to implement that. You can see we get an extension context and we return that we have a PowerShell extension client. Most of this is just setting stuff up. We're working for PowerShell. We've got a log level. We have some telemetry. We validate some settings. We actually go grab those settings. We have our logging. We set up some configuration. Should look fairly familiar if you've ever looked at your settings. We have a word pattern, like what we define as a word in PowerShell. Indentation rules, comments. Shout out to Keith Hill there. 5 years ago, this stuff hasn't really changed because it's pretty dependent on the language. You've got all of your entry rules for stuff. And really the nitty gritty, the next file we're gonna go over to is our session manager. Most of the time, we're talking about a single session in the PowerShell extension. But you can actually make new sessions, and that's with the debug temporary terminal setting. If you turn it on to make temporary terminals for debugging, you're actually getting whole new sessions that are whole new PowerShell processes. And that's why it's a session manager, but we're really just gonna have a single session. So you see I'm making a new session manager, and then the end of this is just calling set language client consumers and if start, call start. So if we hop over into session, the constructor doesn't do a whole lot. Cool thing I like about TypeScript, if you haven't seen TypeScript before, is you can actually define variables in the constructor. And this is actually saying, I want a private field called extension context. And also it takes the value of the first thing that you handed me in the constructor. I really like this cool syntax. I wish that other languages would pick it up, because now you're not duplicating it up here. We also obviously have a lot of fields up there. Just a neat little thing to call out why there's private in the constructor fields. A whole lot of setup. Interestingly, like late last year, we actually finally got to stop making our status icon thing. You see down here the little these brackets, how we've got like ESLint and TypeScript and stuff and a language. For PowerShell, if I pull up in a PowerShell file and you hover over that, where it says 7.3 and has an icon on your version, we used to do that by hand. And enough other languages were also saying, hey, we have a status we want to report to the user, that we actually now have a language status icon like API. And that's why that whole thing exists and moved to the little curly brackets. The curly brackets are built into VS Code. And as we've had to tell so many people, if you want it back down here, you pin it. And I've asked them to make that an optional default, and it was refused. But that's kind of the history there. And I'm talking about that because it's right here. We create a status bar icon. We get to use VS Code language status icon now, and it's pretty simple. It sets some fields and returns much, much, much easier than all the code that we had before. So we've set stuff up, and we've obviously just set a whole lot of fields, and we start registering all of our commands that are available to the user, or most of them. Kind of every class registers its own commands, but you can see like when you've got a PowerShell restart session command, we've actually just like registered it via this VS Code API, and it says, hey, call this function defined in TypeScript, and you can kind of see it does a thing. In this case, on the session manager, it stops it, validates the settings again, and then starts it. Pretty simple for a restart, right? Back and back. I'm just trying to keep us going through stuff. So that's kind of the end of the constructor. And if you remember in main, next thing we do, pretty straightforward, is start the whole thing. So this actually just got revamped. What is it? It's June right now. I spent May revamping the startup logic because it was a bit of a mess. It's pretty consistent now, and I think that we've eliminated ghost terminals. And all of that is like why this code is, to me, kind of interesting, because we do it for the most part correctly and with a cancellation token source. So if you're in the middle of starting and it crashes, or you've changed the setting and said, yes, restart my extension terminal, all of that actually properly is caught, canceled, and disposes like the process that was starting and starts a new one. It used to be that like you could just accidentally be like, yeah, restart. And we've forgotten we had started a process, and you could have multiple PowerShell extension terminals. Hopefully it doesn't happen anymore in the latest version of the extension, and it's because we have a cancellation token and a proper hook for the disposal function. But yeah, a lot of this is still set up. We're creating some directories for the logs and the session files. We're migrating some settings. We're finding the PowerShell that you want to use with a whole lot of logic per platform, per version, and a whole lot of logging. And then we start getting into some nitty-gritty. We need to start the language server process. So if you look at this, we have found a PowerShell. This is mostly just a path, and we're saying, go get it going. Go, client has started, but we need the other half of it, which is the server. And you can see it actually is going to return a promise, a PowerShell process eventually through a promise. That's like an asynchronous await promise pattern. Hopefully familiar if you've written some C#. So that is also in this file. We've got start language server process. And this is where it starts to get maybe familiar if you've ever looked at the logs. We have a whole lot of arguments that we send to PowerShell. So we get the bundled modules path because to make things easier for everyone, we actually include the exact version that we know works of PS readline, PS script analyzer, and pester. So those are bundled with the extension. They exist in the extension folder, and get bundled modules path is just saying, go grab them from here and nowhere else on the system. And we actually make a PowerShell process wrapper of an actual PowerShell process. Constructor, I don't think is terribly interesting. As I showed you before, it kind of just automatically assigns stuff. But given the path to the module from the bundled modules path and whatever feature flags you need, look at that. You've seen this in the logs, I'm sure. A log path, a sessions detail path, and feature flags. You've got more PowerShell arguments like start as login shell, no profile sometimes. Actually, sorry, all of the time, which is interesting because you would think, how do I get profiles in my extension terminal if I'm always sending no profile? We do it later once the process is starting and like LSP is communicated. It's one of the first tasks we do, which is, hey, do you have that setting turned on? If so, go process the profiles, and we'll see that in the C# code. But that's always there to start with, so that we have a really clean state. And like the final interesting bit of it is that we are going to say import a module and then call the one commandlet in that module, start editor services. This is important because it means that we always own the startup procedure. If you attended either mine or Emmanuel's talk yesterday on like isolating your assemblies from other modules, most of the time you need to use that iModule initializer thing to say, hey, do this ALC setup before the module is used, but we own the whole process. So we can just do that whenever we want. We don't have to use module initializer. We just say, no one does anything but start editor services because it's done by an LSP client, which also could be Emacs or Vim. We have some end-to-end tests for that. Yeah, so we have all of that. And now we actually have to start a process. And what does that look like in VS Code? Like I was saying at the beginning, that integrated terminal like idea that came from the ISE is why the extension terminal process that's hosting the LSP server is actually like in the terminal pane. If I hit this and look at PowerShell extension, that's the process. It's not connected to the process. You can see here the command line is PowerShell-login-no profile and then -encoded command, all the stuff that we just walked through in base 64 text. It is one and the same. It's not communicating with another process. It's the process. And that means that this set of terminal options is given to VS Code window.createTerminal, which makes that pane for us, which starts a process in a code terminal. And it's kind of how that ties together. You'll see that we have had a lot of issues around like whether or not this terminal is transient or needs to be hidden from the user or starting in the background. Some people don't like it showing up. Some people do want it to show up, but it always has to exist. So if you have questions about that, come ask us. I think we found a happy medium, which is by default, it shows up and you can hide it. But we kind of hid the option to not just hide it, but like background it, because if you background it, you don't know how to restart it or find it later. So yeah, PowerShell process starts up. And the last bit that the client really has to do is wait for the session file. Now, the session file is only moderately interesting. It's really waiting for the server to get to a point that the server itself has gone, okay, I'm ready. I need a client to connect to me. I need to then give it some details to do that. And in the case of Windows, that's, like I mentioned, a named pipe. In the case of Linux, Mac OS, it's a socket. Those exist at a place on the file system, at least for a socket. And the client needs to know where it is. So we kind of have a shared bit of information, which is file location of a session file. And we write a tiny little bit of JSON into there. That's, hey, we've started. Here's our status. And here's where the pipe is to connect to me. So once that file exists, the client goes, cool, I've got the info. I can connect to it on a named pipe. And you'll see that like we return, we come back to the session, and we can actually start. Well, that's the on exited. We can call start on the language server process itself, which might not be great, well named. But yeah, we'll skip through that. Nope, we just did that. Oh, I didn't hit the back button right. Back. Cool, we've created our process. We're past it. We need to go to language client. So yeah, back. I don't like how the back button works in code. There we go, one level up. We have a language server process. Now we actually have to make a language server client. On the TypeScript side, this is actually kind of happening at the same time because of that asynchronous promise await model. So we can go into here, language client, and you can see there's a whole bunch of connection functions. And honestly, the gist of this is that we're using that VS Code library that's an LSP client, and we now know where to connect to, and we do it, and we register a bunch of handlers, like our send key press handler to get around read key not being asynchronous. Cool. So let's fast forward, because I've got 15 minutes left, into C# code. We've started our editor services module. It has one thing to do, which is start editor services. That is a pretty simple module. Like there's a whole lot of parameters, but it really, really once we're past the parameters, it doesn't have a whole lot. It has an in-processing block, and it says create an editor services loader. I'm gonna kind of skip past assembly loading context stuff, but we have a hosting like assembly that is the loader, and eventually we go through the loader, we validate a bunch of configuration, we're still in the hosting, we've checked our path, and we actually go and start the server. We'll skip load context and move into editor services runner. And the start of this is we've actually need to create our editor services and run until shutdown. It's not, again, a ton. It's, hey, we have a language service transport protocol to talk over. We have some startup info. We need to do some logging. You can see we actually write our startup banner, which should be pretty familiar. Actually just like print out to the UI, the startup banner, cool. And then we create the language server. That's where things get really interesting. The language server, once we've done this and we've called start async on it, and then we've kind of triggered the module to load through the assembly load context, we can actually start talking about doing stuff because we can load any dependency that we want, like Omnisharp language protocol. So, top of this function, PSCS language server, most 30% of the nitty gritty, and then 60% of the nitty gritty is PSCS internal host, and 10% is like everything else. So it has an internal host, and we'll get to that, and that's where we get to go to the completions handler. But yeah, we started up. We're using a library from Omnisharp, that language server. We have a whole lot of options. And this is where, if you want to dive into the C# code and you want to look at like what is this doing and where is it implemented, you look at the handlers. It's a really kind of interesting service injection model. So as a server is starting, we say, hey, here's a class, go instantiate it for us, and it handles things. It handles this particular kind of request. You register all of your handlers, completion handler, hover handler, signature help handler, many handlers, and you initialize the server. And if you note this large note I've got here, yeah, there was a bug in the actual implementation of our library versus like the LSP protocol, and we had to fix some stuff up on like the difference between on-initialize and on-initialized with a D in the end. But yeah, you start it up, and things get going, and you start the internal host. And I am going to skip to the host, which is right here. Like I said, host is 60%. This is a massive file. It's kind of the monolith. It actually has some stuff that may be familiar to you if you've looked at like system management automation and used APIs from that. It's got like a PS host user interface. We create our own like actual PowerShell host. We're one of the few people out there who have a production instance of a host that's not just the default host in PowerShell. We have a Visual Studio Code host. And that's actually why your profiles in VS Code have .VS Code in the name of them, because it's a separate host. Like little used functionality of PowerShell, we're one of the few who uses it. Lots and lots of fields. I do just want to sidebar on this. If you look at the start of PSCS internal host, the static function with a whole lot of reflection where we're getting like script debugger and importantly transcribe only flag and a whole bunch of settings around this. Yeah, we just had to fix a really big bug in Windows PowerShell where the output would disappear because a previously fixed bug in PowerShell 5.1 in the out default commandlet could have transcribe only accidentally stay true, and your output would disappear when it was still true because it was transcribing only and not printing it out. And yes, it got fixed, but it's fixed in PowerShell 7. And well, how many of you use PowerShell 5 still? Right, like quite a few. And so if you got it into the state where transcribe only was still true, you just wouldn't have output. And our fix for this, because we can't fix it in PowerShell 5.1, is to just reset it. And we had to do that through a whole bunch of annoying reflection, and that's just the setup of that code. That was last May. It was a doozy. It took me like 3 tries and 3 releases, and hey, I'm just glad we fixed it because it was reported over a year ago. But yeah, you actually start up like the PSCS internal host. This is where we actually have like our read line provider, and we have stacks of tasks. Sorry, that was really loud, tasks. Because the old architecture was just kind of like, hey, I'm a PowerShell process. I've got an LSP request. I need to go run that in the pipeline. Something else might already be running too. And it was sort of this weird like asynchronous model that didn't work because it wasn't meant to be asynchronous. And so things just like kind of stomped all over each other. So the rewrite that Rob had started and that he and I kind of got to finish was this actual like queue, a blocking concurrent deck, in fact, of tasks to run, along with the ability to say like for a particular task, if it has to interrupt everything and move it to the foreground. So what this now means is that like architecturally, when VS Code and the extension are sending LSP requests, those are coming over the wire. They're coming to the language server protocol server library, Omnisharp. That is doing request handlers, and then it's actually just queuing PowerShell tasks for us. And we have one pipeline that's processing in a while loop. Here's a PowerShell task. Okay, run it, do the thing, return the value, and then do the next one. And this is cool because now you can go to like your extension terminal and type out everything you want to do and run a new thing and interrupt everything. Literally, when you run something and hit enter, a new task gets queued that says requires foreground. And it goes, oh, I need to pop to the top of the queue. I need to stop whatever else the server is doing and actually start executing your task, which means it properly cancels stuff and it can get serviced immediately. And as soon as it's done, the other task can start going again. This has been incredibly helpful. Like our architecture actually mostly works. Again, I wish that it wasn't blocking, but that's kind of just the nature of sharing the context of that pipeline with the extension terminal and the requests that are being serviced. And as we talked about earlier, that was sort of a desired feature. Yeah, so we have a stack of those tasks, and if you get into all of this, you'll see both familiar and unfamiliar stuff like PowerShell instances and debug contexts and frames and pushing and popping run spaces to handle all of this. And one of the few functions I unfolded here is like the startup stuff. So if you remember, I said we don't actually start profiles immediately. We actually say, hey, you sent the option to load profiles. This is a great just a little segue into what a task looks like. So we call our function load host profiles async, and it's cancelable. And we call execute delegate task. It's called load profiles, and it's literally on a PowerShell object called the load profiles function with some profile paths. Load profiles just is, it should be familiar. It's a PS command, and we just check, does the file exist? Cool, execute it. We build up that command, and we have a great little function, one of many, that queues a task. We invoke task on pipeline thread asynchronously, which really just means we have a thing to go run, we know when we want to run it, queue it, and go let essentially like an event processor run through that stack. So that's kind of like the deep dive that I really wanted to get through. And since we had the ask earlier of how do completions work, let's go look at the completion handler, yeah? Cool, and I think that's great because like one thing we haven't looked at is what a handler looks like. So I will go back to the language server. I'll scroll up, I'll look through all of these handlers, and I think I saw it. PSES completion handler. I'm gonna jump to the definition of that. And it's actually not horrible. Like in terms of complexity, there's a completion handler base, and that's a class in Omnisharp. And this is great. I don't have to write like implementations of the protocol for a completion notification and like the return of a completion notification. I actually just get to implement that class, call it PSCS completion handler, and do what I need, which in my case is like have a run space, have an execution service, that's actually the host, and have a workspace service so I can like look at stuff in the workspace. Registration options, not super interesting. We were kind of saying it works for PowerShell documents. It's a resolve provider, and it triggers on these characters. It's also where like we check if there's snippets to support and those commit characters, and whether or not Markdown should work here. But this is the implementation. We handle a request on this handler, right? A handler should handle a request, and it has some parameters. which is a record from Omnisharp. And if we look at that, I didn't have to write any of this code. A completion params has some context, a work done token, partial result token, and a whole bunch of equals, and probably more importantly is completion params down here. No, not that. Well, we'll just look at how it's used. It's probably on completion context. Yeah, trigger kind, what triggered it, and more context for it. But yeah, we'll hop back. Back. Okay. So we're handling. On that request, we have the position in the file, like by line and character. For historical reasons, annoyingly, we've always got like a bit of an off by one to calculate. The PowerShell scripts in our code base start with 1, and everything else in the world starts at 0 because we're programmers. Don't ask me. Yeah, we get a script file. That comes from the workspace service, a script file. You would expect it represents a script. It has the PowerShell version on it, and it has the path to it, and a URI for it, whether or not analysis is enabled for it, but I actually think that needs to go away. And the contents, and a buffer range, and some diagnostic markers, which might be familiar to you because you've seen diagnostics in VS Code. And I've got 4 minutes, great. So we have our script file, back buttons, the bane of me. Gosh, completion handler. And yeah, we actually just call get completions and file async. I say just, but we've got our script file from the request. We know where the cursor was, and we have a cancellation token because you might not want the completions for this anymore because you may have continued to type, or you may have executed something in the terminal, or any other 1,000 things should say, like, hey, throw that work away. And don't like wait for it to complete, just cancel it. That was actually one of the great performance improvements that we managed to make, was like Patrick and I going through and saying, oh, we should be able to cancel most of these requests and actually like stop waiting for stuff that isn't useful anymore. So yeah, get completions and file async is the meat of all of this. It's a promise. It returns a set of completion results. And that's just PowerShell code right there. AST operations, like walks over the AST. I mean, we've implemented this, but it uses the PowerShell AST like APIs to call for completions given like the script file grammar that we've got, not grammar, but the AST for the script file and the tokens that are in it and where we are in it. If we look at that, this is where you'll actually see, hey, we need to go execute delegate async like we did load profiles. This says, as the very next thing to do, so high priority because you want your completions fast, get that internal host, one of those earlier files we were looking at, and make a synchronous PowerShell task that runs tab expansion too with the ASD and the tokens and the position, and go run it on the pipeline in the queue. So cool, that makes a task. The event processor is running that task queue. It goes, I need to check if any of these are next priority. Completions are. Run this task, call PowerShell, like invoke PowerShell. We're in a PowerShell process. Invoke the PowerShell pipeline, get our completions out of it, check that we actually got them, and then return them. So yeah, we'll get a set of completions from here. I think if you scroll, it goes back to where you scrolled from, and I think that's what hangs me up. And yeah, we get a completion result, command completion. We check if it has matches. Like if there are no matches, we were incomplete, and we return an empty. And then if we need to complete, if we actually had a match, well, cool. We need to see what we're going to replace in there. 1 more minute. And so we calculate our buffer range. We check what text there was to be replaced, and we get the new text from the completion, and then we return it. So you'll see completion items come through, do a bunch of processing over those items, and return new completions result. And that's it. The library underneath Omnisharp handles that. It sends it over the wire, and it comes back over to the side of things in the client. And there's actually no code that I had to write in TypeScript to handle this. That's the magic of LSP. That's my talk.